Thank you, Matthias. And just to clarify, when I took my PhD, they're all called Doctor of Philosophy, but I'm not a philosopher. That was actually a PhD in psychopathology. And so that remains more within the realm of my usual stuff. So my objective today is to tell you about our experience with using large language models to teach statistics, a field which I think is exploding because, as we'll say, there are several offers already for universities to use these approaches, and also to give to those who don't know much about what a RAG system, a retrieval assisted generation, is. Just to give rough details, because I think that it might be informative as to how these models may be used for a variety of applications. So what we were doing, we developed a standard RAG application. I'll explain what it is, to help students to executing their exercises, to help with questions that they might be reluctant to ask, and to discuss material from class and the textbook. Now, the second point was a primary motivation in my case, because my impression was and is that many students are reluctant to ask questions because they think that their questions are stupid, which in some cases is not totally unfounded. But nevertheless, it's not always unfounded. I think it's also an issue of personality. And as a clinician, I think I know that very many young people, not only young people, especially young people, have a very negative view of themselves. And we don't know who they are, but that is a problem for them to come forward. Okay, so that's a bit more of a psychiatric view of how things work in the classroom, but I think it's very good. So the idea is that even when having a system of this kind, they would be more prepared to ask questions that perhaps they wouldn't be asking otherwise. And also for people who don't have this kind of inhibitions, there is a large increase in the availability of the system, because practically the system is always online. So they don't have to choose a time or be there at the lecture. So, and as I will show, the idea gradually developed into that of building a kind of digital twin of the lecturer, an individual lecturer, not the lecturer in statistics, but an individual lecturer, so that it contains the material that this person specifically uses in his own or her own classes and exercises and books. And I perhaps show at the end, if I have time, a bit more about that. So students were first giving they were accessing the system through the OLED system, and they were giving their informed consent, where we also explained that it was a machine and it was not a person, which I think it was pretty obvious. And then they were presented with this application, which looks very much like a chatbot like ChatGPT, but the difference is that it provides information on the specific issues that were present in the course. For example, if one asks, and we have a lot of examples with notes of kids whose mothers have depending on, predicted by mothers' IQs, if there's something, but what are the predictors that we were using, to predict child IQs, the chatbot would be able to give a reasonable answer or recall the models that we were discussing in class, which a general chatbot would not do. Now, to give you an idea of how it was working, I have my two assistants who helped with developing the thing and were actually interacting with students. Very important, I think, we also, with help of my assistants, we gave demonstrations to students about how to use this chatbot, because I think it's very important to clarify how it may be used to learn things, not just to get some kind of answers. Please just give us a couple of examples of how the system works.
we would like to give you a demonstration how the system works and which kind of questions the students asked often. A lot of questions were asked were answered pretty well, but also there were a few questions which were more challenging or more misleading. And yeah, we start with a very common question. A lot of students ask for interpretations or from different outputs. And one example was, how do I interpret the odds 0.88? So wait a second for the answer. And here we see pretty similar to other chatbots interpretation. And here you see a general interpretation of a definition of odds, and then here's more specific for 0.88, what it means, and we got our correct answer for this type of question. But of course, the system was often the problem was the kind of question from the students. The answer is often as good as the question is. And we had, for example, a student who asked what kind that was a question from a student, and it's a super misleading question because in NAS was just the name of our data set and not a specific data format or something. A few months ago, when the student asked the question, he got an answer, and it was a wrong. Okay, here. Now he tries to answer the question with her Nintendo Entertainment System, but obviously was not the question the student wanted to have.
Oh, maybe now we understand what the question was. I mean, I don't know. I didn't understand that. I didn't know about Nintendo, but.
And as an example, we tried to challenging the chatbot and find some hallucinations. And one thing I can say, it was really hard to find wrong questions, what is really good for us. But yeah, that's a little example for a wrong answer, or not the answer the student wanted to have.
Yeah, I think this is also a very good example to demonstrate that, like Magdalena said, the question is only going to be as good, that the answer is only going to be as good as the question is. And this is something that we told our students as well. We told them to try to be specific in how they ask their questions, because that's going to help the system to produce correct answers. So let's try this. The student had more information in this case, but decided for whatever reason to not give those information. So for example, we could ask, what kind of data format is NAS.dta? Let's see how the system reacts to that. Yes, this is much closer to what we wanted to hear, or what the student wanted to hear in this case. And we see that we even get a little instruction on how to work with this. So we can use in R the function read.dta, with the foreign package. So the student automatically gets a little bit of an instruction on how to work with this for this specific problem. So yeah, I think it just goes to show that the more specific we are in how we ask questions, and the better the questions are, the better the system is going to respond to that. Yeah, and like Magdalena said, we try to challenge our system a little bit, and we try to get it to produce wrong answers. And like Magdalena said, it was really, really hard to do that. And one question that we asked, which was misleading in the first place, was in logistic regression, the outcome variable is continuous. What kind of scale type does the outcome? So what we're asking here is, the question already contains a mistake. So in logistic regression, our outcome variable is not continuous. It's categorical. To be specific, it is binary. So it takes on values of 0, 1, yes, no, etc. So let's see how the system works with that. Yes. In logistic regression, the outcome variable is actually binary, not continuous. It represents two possible outcomes, typically coded as 0 and 1. This is exactly what we wanted to hear. And then it goes a little bit to show what the case is with Poisson regression. Is a count variable, which means it's discrete. This is exactly what we wanted to hear. It's a perfect answer. So it goes to show it's not easy to mislead our system. Even if the students get something wrong and they put little mistakes or even bigger mistakes into their questions, the system is going to be able to identify them and to react to it accordingly. So yeah, I think this is a pretty good demonstration of how the system works in general.
Okay, thank you. So if you don't have any question about this, I will just go ahead, because so we don't spend too much time on this. What I wanted to explain to those who don't know very basically is how this system worked. It's a RAG system, which is the most established and easier LLM application. So what happens is that when we think of ChatGPT, we have, of course, a chat interface to the model. And in the early versions like ChatGPT 3, that was almost a direct interface to the language model itself. But in LLM applications, the language model is only one part of a more complicated program where the language models play multiple roles. So the idea of the RAG is that the information that the model uses to generate the answer is provided by the author of the system. The information is stored in a database. Here, the documents is called the index sometimes. And when a user asks a question, the documents are retrieved from this database that are closest to the meaning of the query. And these chunks of text are then given to the LLM together with the question to generate a response. That means that the LLM is used in many steps in this system, and to recognize the meaning of the query, to encode the meaning of the documents that we have put in the index. Then this is the main generator that generates the answer, but there is also another LLM here which is checking that the answer is not in a content that, I mean, Nintendo should have been excluded, I think. I don't know why it didn't exclude it, because it has the instruction not to allow anything that's not in the objective of the thing. And then there is an evaluation of the response. So if you read about LLMs, there are basically I think there are two approaches. One kind of people say that we will get so much about LLM because they achieve artificial general intelligence, this AGI. They will be omniscient. They will know everything. They will just be able, like this, to respond to queries and figure out things. And this is this big LLM here. But there is also another version where the LLMs are viewed as a kind of chips that compute things, and we instruct the chips. We give the instruction through text instead of giving instruction through a code. Okay, so applications results from the use of small LLM. I mean, they're cheaper, they're quicker. Okay, they cost much less, and they allow us to tailor the application in different ways. So they start with the ingestion, that is, the LLMs encode the meaning of the chunks that we get into the vector database, the special database that we use, and then the database provides the information to us. So a very important aspect of this is that the knowledge that's provided by the chatbot is influenced by the knowledge that we give into the database. It's not just directly what ChatGPT or any other language model provides. So the most interesting aspect, I think, is that of replacing what ChatGPT might be saying or not be saying with what we want it to say. And so that's the specific knowledge that I have highlighted here. Also, the system is flexible and adaptable in the sense that I can start with a basic storage in this index of information and add to it dynamically, as it happened during the course. We were adding things like exercises or answers to questions that students were giving that we can monitor from the system, so that the system also acts as an interface to the students through which we can learn how they student, what they want to know, and we can put our own content into the system so that the system grows with the time, with the experience that we collect. So we did this by doing some preliminary testing. We tested the RAG system with scientific materials first. I don't have data on that, but we also tested the recognition of semantic content. We had a database where we had two scales, and these scales give responses that are associated in people. These are one normative scale and a clinical scale. And for some of these associations, the reason is that there is a semantic relationship between the questions that are asked in these two scales. So what we were testing is the capacity of the different models to recognize the semantic by looking to what extent were they able to predict when the answers from two questions or two subscales were correlated. So the model doesn't have any knowledge apart from doesn't have any knowledge about that. We know that the answers are correlated. For example, neuroticism and negative affect are very correlated, and we see here that this is also due to the fact that they have a small semantic distance. So they ask similar things, these two cases. That is why people give the same answer. And this is the fit of the best model, which was at the time, it was summer. OpenAI, the large, and it scores definitely better than the small one. Okay. It can, so we had an idea of what we could use here to encode the chunks and the performance of these things from our own research. Now let's go to performance. As Sarah Magdalena said, it was not easy to find fault with the model, and this is a bit of a breakdown from an evaluation of what went on. So we had a very large majority of correct answers, correct satisfactory answers, generally because the questions were a bit vague. And then we have a number of inappropriate questions, really very few questions that we thought that were answered incorrectly. Any questions here about these parts? So the usage at among students, so more than half used it. Some people did not use it. The system ran between Christmas, just before Christmas, and end of January, and they generated 271 queries. There were not so many students in this class, so there were fairly more queries than I thought, actually. But this user statistics turns down. I mean, we asked them at the end if they used it or not. It's a bit misleading because those that reported not to use the system, 3 subsequently commented on its utility. So what happened was that some people that looked at it or not used it actually were using ChatGPT and not the system. So I didn't ask this, I didn't expect this, because then initially they came out towards the end of the course, yes, but what's the difference with ChatGPT? Well, you get ChatGPT if you want, because ChatGPT is behind it, but you get the material from our course on top of it, okay? But they were thinking that some people were thinking they would be better off with ChatGPT. So unfortunately, I don't think we have a real statistics of what the students were doing. I think what they were using language models much more than this statistics reveals, okay? Was the chatbot useful or helpful from those that used it? Helped, not essential, no difference. Also here it's not clear, it's not essential. What's the reason for that, given that they had recourse to something that was not the chatbot itself, and didn't realize it was the same engine behind, only augmented with the information. But in general, it helped. And very important for me, I asked questions that I would not have asked otherwise. So if they did use the system to ask something they wouldn't have asked in the lecture, because it concerns material that we were using in class, and that was true for, or somewhat true for, the vast majority of the students. As I said, that was the main motivation. So what kind of questions were posed? So this is a breakdown of the semantics of the questions. You see there are some sort points, loading files is a big sort point in my experience. You don't know here, the student psychology don't know how to load files. It's big problem. There are some people who don't know how to unzip files. So that's a big problem if you teach statistics with the R and the person doesn't know what a zipped file is. Something to think about when we talk about digital competence, right? Then, because you can have fantastic tablets, I think, but you don't know web files are stored or where they end up. And then there were the classic questions. Now, this is the internal representation of ChatGPT itself on the semantics of the question. I mean, how it was seen. Well, not exactly, because this is a two-dimensional representation. It has 1,200 and something dimensions instead. So the ones in the middle here are not really resolved. And these are interpretation of output in both cases. But here on the left, they were just putting the whole output in the question. And here we're just asking very short questions that were not clearly interpreted. And if we look at the types of question manually, so that's about what they were doing. And also, I think here comes out that they were familiar with ChatGPT because they were asking things that we did, or I didn't demonstrate, or we didn't demonstrate because I didn't think of them, but it's something that ChatGPT spontaneously suggests students should do, like creating exercises for them to practice their skills or something like that, which our system was not programmed to do. I mean, I didn't put any exercise in the system because also time limitations. I mean, it was just lecture and questions, but not other things, or summaries, for example, were not there, but that was due to the time. Now, an aspect that I think is important is that if this thing is generally intelligent, the question arises if you should really replace this thing entirely. And in the model that we implemented, the language model was allowed to generate its own answer. So if the material that we put into the system did not have information then the model will just generate the answer that you generate when you just chat with ChatGPT. Now, I was doing that because I didn't want to start creating material like, very extremely basic things, and especially a model that could help with the error messages of R, which I don't have an oversight on. I don't know what can happen with it. I mean, I know some messages, but I just don't know what can come out of it. So the idea is that allow the system to respond when there was no material, and then to use another LLM after the fact to check what the system was saying. So if you ask, why is the sky blue? The system actually produces an answer, and the answer is blocked here at this stage. But that's optional. I mean, that you can say, no, just use the context. And in this case, you limit really to what you are doing. So there was some kind of AGI, artificial general intelligence, that was exploited here, but it was tailored further to the content of class. Okay. So when won the context used and when not? I'm not entirely sure because I asked the model to tell me this was the case. So that's about, there was almost a third of cases where the content was not used. And the breakdown is this one. And you can see interpretation output, especially RUs, was half of them was not covered. But that was exactly what I was thinking. I was hoping that this would be a bit less, but the advantage is that since you have the question users ask, you can expand your index database and cover these cases as well if you think that is worthwhile doing it. And for the cases where it's not worthwhile, like these ones, okay, so you just leave the model to take over. Okay, here I'm asking for material. I mean, this was not. They were asking for new material to learn. Like there was a couple of questions like, can you provide me small files, small summaries that I can use so they were asking that, and I didn't think of that at all. Okay, so this is this material. There were three queries, and the model was mostly just figuring out what you can. Okay, then another interesting thing. What were they using to prepare the exam? And so there were a couple of performers that just used the lecture. I don't know what note they got because it was anonymous, this thing, obviously. Lecture notes is a favorite approach and exercises. And surprisingly for me, because I belong to a generation that, I mean, I use textbooks all the time, and they don't use textbooks at all. And it turns out that I didn't figure out here by this query all alternatives. It asked me if they're using ChatGPT, for example. It used to be using YouTube, which I think is a large source of learning material for students nowadays. I think I hadn't really figured out before doing this thing. Okay, and so what is going on? I mean, if you look, education, I think, is one of the main areas where these developers of the foundation models think that they have an application. I think there are two areas. One area is this one, and the other area is replacing workers. I mean, not physical workers, but and that's the second is targeted by venture capital firms. I'm sure that they can reduce headcounts in firms, and this one is done directly by the language models developers. So DeepMind has a group whose target is students. So if you go into Gemini, you can ask Gemini to provide you a course, and you interact with Gemini through the course. OpenAI has a program for school and university administrators to provide lectures and education material. And then there are other also other actors. Khan Academy is not the only one, but they have been producing learning material for years, and now they produce their own chatbot that is offered through the ChatGPT interface. And then we have institutional agreements like the one I got that we have here. I don't know what it does actually exactly, because it's just access to ChatGPT. I asked them, didn't get any answer. But there are also places like Estonia who's striking contracts directly with OpenAI and Anthropic to provide access to the models in schools. I don't know exactly how it works, but this is what OpenAI offers. So, and it is tutor. Okay, so that's how it works. So you see that the field is moving towards the existence of standardized offers of courses, okay, that in the experience we made, and also because students anyway tend to go to YouTube to find alternative lectures, I think they have a good chance of, in the next years, perhaps not next few years, but in the medium term, to be very successful. And also, I'm saying this also because our experience of the performance of the chatbot was surprisingly good. The chatbot chats with you in any language. Just, you can ask in French, Italian, Estonian. It will, with the same material in English, it will produce the translation of your question. It improves. I mean, I put my material into it, and when it uses my material to create the answers are extremely well formulated, so that I would need much more time to create these answers than. So it improves the material you put there. And they are extreme, and they might not be good at creating poetry. I mean, they make fun of ChatGPT or creating poetry. But when it comes to creating standardized content, it's very good. The personality of these models differs. So OpenAI turned out to be the one that was most didactic without any specific prompt. The others needed to be prompted a bit, especially Gemini. Gemini, I don't know now, they have new models, the Flash model, but Gemini was producing extremely high-level answers that I think they were not appropriate for students. So I had to put something in the prompt like, you are a high school professor or you're a university professor teaching students, blah, 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 so that it would just change completely the tone that we're using. So now, thinking of this, I will give you a couple of thoughts about what I think might come next, or what I would like to do next. So I think that one thing that has not been taken into account sufficiently is another kind of user, which is faculty. I mean, we have this development whereby faculty is at risk of being replaced almost entirely by these models, at least for standard courses. But I think there is a role for faculty to play if they can become the authors of this kind of offers. I mean, we don't need to just have the ChatGPT course and nothing else, or we can start from a standard course and give colleagues the opportunity of creating their own AI teaching approach, right? So that they can put their own stuff in there. So one idea I have is that already now, if you use Markdown to put down your ideas or your material, you can use Markdown to create a textbook, because Markdown can be compiled into a document, or slides, because that's something that Markdown does as well nowadays. So you can just directly generate the slides from the Markdown. And I think it wouldn't be that difficult to use the Markdown or a similar interface for faculty, so the faculty can easily create a chatbot, perhaps starting from a standard core. So as I was using ChatGPT as a AGI that would solve the problem of understanding the errors that students were making with the R programming language, right? Perhaps supplementing that with the material they have. You can start with a core and increase the index with your stuff. and uses something that creates a chatbot. It can be offered and refined without knowing much about how these applications are programmed. And I think also, given the tendency of students to go to YouTube, you could also create an interactive webcast with the same system. That is, instead of giving just the text, the slides, and the possibility to ask questions, you could also create the lectures like this YouTube stuff that's around. But in addition to that, this YouTube could be stopped and you could interact with the lecturer, the virtual lecturer. So getting a step closer to this digital twin of oneself, always with personalized content. And I think this is decisive because the standard content will already be delivered. So I can perhaps give an example of this. Let me just stop the server and give you an idea of this prototype. Now this is just, I didn't put so much material into that, but this is, and it's not the interface that I'd like to have, because this was developed a bit quickly. What is this? Yes. Let's go back here to this thing. So the idea is that I can give the opportunity, okay, to a faculty to create simultaneously all these systems. Okay, so this then the AI takes care of translating this into a lecture that now I'm not hearing because I think of this thing here. It's not loud at all. I mean, you can hear that it whispers something. And then I can stop here and ask a question. Can you explain again what is a linear predictor in logistic regression? Okay, and the question is first translated into text so they can fetch from the database the relevant context and not give it directly to the language model.
Similar to what you specified in preliminary linear regression. It's a combination of the outcome and variables in the model.
So it comes in answer, but I think that sharing the screen or something leads to some kind of muting, I don't know, because otherwise it would interfere with my voice, I think, if I hear something from there. I don't know why it's not, but it answers the question, okay? And the challenge with this, I mean, it's not difficult. I mean, OpenAI gives you now a direct connection to the language model through talking, okay? But you can, but the challenge here is that of using the RAG system to create really something that would give answers on material that possibly is not contained in a standard lecture course. For example, if it is very advanced material, or simply that you want to put your own exercises and your insights, your way of explaining things, sometimes there is something like that is important. So experience that you have gained over years of teaching, how you convey these things. So I think this is a direction that's interesting, also because technically it's a bit more challenging to develop a conversational agent than to just put together a RAG system, which is a fairly standard thing that you can give. Now, so something about the legal aspects, and I don't think there is anyone here from. So I'm just very Well, the problem is that the AI Act has listed education application as high risk, but it's not clear that they mean all applications. For example, in their example, if one uses AI to determine who get course to notes or get access to a course, something like that. But so there are 4 levels, maybe you know, the minimal transparency risk, high risk, and acceptable risk, and an optimistic interpretation, because I think it's not very clear what they want, is that the educational RAG belongs to transparency risk level, which has been taken care of in this implementation because there is all the chatbot there, and in the informed consent, they were informed that's a machine, it's not a person. And then I have my personal issues with the GDPR, which I think it's a real catastrophe. And I hope that the AI Act is not going in this direction, but the fact the national legislation may be more restrictive and the individual is a recipe for problems. Okay, thank you. We have a small financial support from the Retrieval Digitalisierung, and this is our contribution. Thank you.